The automated system based on the laboratory stand and software which was implemented in the educational process for application of AMD device functions is considered in this paper. The device can be demonstrated without being connected to the computer. Instead, when the device is connected to the computer, the software analyzes the status of AMD device using the Modbus protocol. The objective of the developed automatic system based on the laboratory stand and software is to realize the function of devices of AMD product series during laboratory work. The student will have the opportunity to study the operation of the switch controlled by AMD device, get acquainted with the processes of data exchange during switching between the main and backup power supply links, and carry out the process of generator control. Figure 1 shows the main device of the laboratory stand without computer. Figure 2 shows power electrical panel. In order to increase visualization and practical application, the developed system was integrated in the training SCADA system energy of the hardware-software complex Arrow, which is designed as a simulator of the automated dispatch control system for research and control of the operation modes of electrical power systems. To exchange data between hardware-software complex Arrow and AMD device, the program based on the Modbus Arturo protocol was developed. The communication channel is used to exchange data with the device of the laboratory stand. The data are transferred into the equipment model where the messages are processed. Next, the data are transferred to the real model where the final processing is carried out, fixing the message in the database analysis and emergency situation, and saving information about the current status of the model. During the work, the student uses the graphical model that provides a request for input of a real model and outputs in it a form similar to the user, mnemonic schemes. Figure 3. The developed program file of the Modbus Arturo device map and the automatic control unit itself are the real model of the training SCADA system energy. To integrate this model into the SCADA system environment, the graphical model, which is shown on Figure 3, and configuration file containing the following data were created. The development of implementation of the software was carried out in Microsoft Visual Studio environment. The diagrams were created in the Borland Together design environment. The project schedule was implemented due to the Microsoft project, and the work of communication and Modbus registers was performed using Modbus POL program. The basic switch energy program consists of several modules, each of which perform its own task. The division of the program into categories and modules is shown in Figure 4. The power connection of the primary and secondary sources and the load are graphically represented in the program as well. Figure 5. While using the program, the student observes the control status of the generator, which power source is connected to the load, which electrical lines are energized. This information is transferred from Modbus bus and is used to update the chart to reflect the real status. In animation in the operation mode of the program, then the chart graphic is created on the basis of Modbus bus data due to Modbus data injector subprogram. The software representation of the lines on the diagram is quite time-consuming during programming. In the real device model, the animation of the lines is not displayed, and the connection of lines to the power supply is obtained directly from Modbus requires data. Animation is not displayed in the operation mode of the real device. The student is able to observe the current situation and change the electrical network. The communication connection between OMD device and computer is created by means of required converters, the type of which depend to the computer configuration. Communication between OMD device and computer takes place according to the Modbus protocol, where the main device sends the request to which the involved device responds specified in the request. Schematic implementation of the operation of the presented automated system equipment is shown in Figure 6. The general view of the proposed software is clear and visual. It contains three images with the diagram: voltages on the electrical conductors, the statuses of the main switch, as well as the command from OMD device to the generator and electrical networks. The view of program where the diagram with colored lines clarifies the information is shown in Figure 7. The image describes the conditions of primary and secondary links to the electrical network and the equipment connected to the load. The program graphic consists of electrical circuits, red and green line in the diagram, OMD device, and load switch that performs the switching. OMD device controls the generator of the second power supply source, blue line. In addition, the program has three images showing the primary power supply, top left, the secondary power supply, top right, and the training lab load connected to the power supply source, bottom middle. Colors and brightness of image change depending on the activity of the device or image object. The view of the program window is the function presentation model is shown in Figure 8. Light indicator shows the receipt of electrical energy by the laboratory equipment, Figure 9. The objective is to develop automated reserve input system based on the laboratory standard and software for communication with OMD switch control produced by ABB company. The developed software is very simple and supports illustrative and educational applications. The developed program has two modes of operation, with and without OMD device. The program graphics make it possible for the student to get acquainted with the function and capabilities of OMD devices and additional function. In practical, exchange animation and wallpapers. Language selection is available, English and Ukrainian. The connection of external equipment to OMD is designed in accordance with the requirements of switch energy program using Modbus protocol. Information transmitted by protocol about the current status of OMD device can be presented in the program both graphically and verbally. The animation model has also been developed for the program. It makes it possible to present the function of OMD device without physical connection to the device. Thank you.